Hello everyone, let's integrate sine inverse x or arcsin x. Now, this I specifically wrote not the derivative of sine inverse x because, well, some people when they see this they think, oh, it's easy, it's just 1 by root 1 minus x squared. But that is in fact the derivative of sine inverse x. So let's find out the integration of sine inverse x. Now, it would be kind of easier to compute this if, well, there wasn't the inverse x, the sine inverse, right? If there wasn't the arcsin, it would be very easy to compute this. So to remove the sine inverse, we need to use the property that, well, sine inverse sine x, well, the inverse function, sine inverse function is basically the inverse function of sine x. So when they're together, they cancel, giving us the x back. Kind of like how e to the power x and ln x are inverse functions of each other, and when they are together, they simply cancel each other, giving the variable back like this. So we can simply use substitution method, and here we can substitute, let's say, sine theta as x, or x equals to sine theta. Now in the next step, we obviously differentiate both sides. So this is cos theta d theta, and let's just put it back here. And also I'm going to write a comma that theta is equals to sine inverse of x. Basically taking the sine to the left hand side, or sine inversing on both sides, it's the same thing. And this becomes theta dx is cos theta d theta. Now this is very easy to compute. All you need is integration by parts, or the simple DI method. Differentiate theta, integrate cos theta. Differentiate this once, we get 1. Again, oops, not theta, you'll get 0. Integrate cos theta, you'll get sine theta. And again integrate sine theta, you get minus cos theta. And our answer is this and that. So we'll have theta sine theta, minus minus plus, be careful for this minus right here, plus cos theta, and we can just put back into the x dimension. So our theta is sine inverse x, and sine theta is x plus cos theta. Well, now we need to find what cos theta is. So let's look at this right here. We have let sine theta as x, right? Now, please do not forget the basics. This sine angle is simply, well, perpendicular by hypotenuse, right? And we can just let x as x by 1. We can look at it as that. Comparing, we get perpendicular as x and hypotenuse as 1. So if we draw a right angle triangle, our hypotenuse will be 1, and let's say this is theta, our perpendicular will be here, base will be here. So our perpendicular is x. And using, well, the Pythagoras theorem, this is 1 square minus x square. 1 square is 1, obviously. So simply we can get our cos theta because we have found our base. So cos theta is our base by hypotenuse, which is root 1 minus x square by 1. But we don't really need that by 1, so it's just root 1 minus x square. Now we can just simply put that back here, plus c. If you want to make it nicer, put it x sine inverse of x plus root 1 minus x square plus c, and that is our answer. So if you notice something, when we integrate sine inverse x, we again get sine inverse x back here. And, well, if you learned something new, please like and subscribe. Don't forget the basics. Thank you.